of sine 80. And we know what sine 80 is in exponential form. A half e to power 80 minus e to power 80. And we can write it in the Laplace form, replacing the sine with its exponential form. 0 to infinity for the integration of semi-infinite integral. We bring the half out and we write e to power minus st times, open bracket, e to power 80 minus e to power minus 80 dt. And we can expand the bracket and simplify using indices. So a half integral from 0 to infinity and then we write e to power minus open bracket s minus a close bracket, bringing the minus t out as a common factor, minus e to power minus s plus a t and then dt. And now so we're going to integrate. So we have a half square bracket, and if you integrate exponential, you get exponential back, divided by the derivative of its exponent. So that's the exponential, we're getting that back, divided by the derivative of the exponent with respect to t, minus, we do the same thing, exponent back, s plus a t, divided by the derivative of the exponent, s plus a. And we're going from 0 to infinity. Now we need to write a half, bring the denominator out because it's a constant, so minus 1 over s minus a, 1 over e to power s minus a, infinity minus e to power 0, minus, again, minus 1 over s plus a, open bracket, 1 over e to power s plus a, infinity minus e to power 0. And a half, open bracket, minus 1 over s minus a, open bracket, 0 minus 1, because 1 over e to power infinity is 0, and e to power 0 is 1, minus, open bracket, minus 1 over s plus a, open bracket, again 0 minus 1. and we have a half into bracket, open bracket, times minus 1, that'll be 1 over s minus a, minus 1 over s plus a times minus 1 over s plus a. Now we need to find a common denominator and simplify. So cross multiply and then multiply the denominator. A half s plus a minus open bracket s minus a divided by s times s squared, s times minus a, s times a, that cancels out, a times minus a is minus a squared. So we get a half over a half, that's 2a over s squared minus a squared, and that 2 will cancel out, a over s squared minus a squared. So now we can write a Laplace sin at that equal to a over s squared minus a squared. Some example: sin 3t equal to a is 3, so you do 3 over s squared minus 3 squared, that's 9. Another example: Laplace 2 sin 4t. That will be equal to, well, that's 4 is a over s squared minus 4 squared, 16, and then you times it by the 2, the constant, that would be 8 over s squared minus 16.